Right. So good morning, good afternoon, everyone. I see some more people are joining us, so let's wait for a couple more minutes before we start this webinar with the team that we have here. We'll wait for another minute. I see some more people joining us. Let's give the audience a couple more minutes. I hope you can all hear me well. All right, so let's give it a start. So good morning or good afternoon, everyone, depending on where you are. I know some of us are based in Europe. Some others are based in Southeast Asia. We have Rites, Kusum, and Marinal here today with us. I'm very happy and very excited to have you here with us, where we will be talking about how they supported their growth at Simplilearn by decoupling their systems and how they have done it with the help of Ivan. Before we do that, maybe just Kusum or Rites or Marinal, do you want to tell us a bit about yourself, what you do at Simplilearn, and what are you mostly interested when you work with open source technology specifically? Maybe Kusum, you want to start?
Yes, definitely. Hi guys, I work as a principal architect with Simplilearn and look at the technology vision of the company. So I work with the application, infra, and data warehouse architecture teams, and I'm usually architecting solutions for product innovations or auditing and planning implementation of security or compliance across our various applications and infra as well. So I mean, it's more about evaluating new technologies, finding new products, looking at what will suit us best, and then implementing that as part of our applications. And personally, I like learning new things and improving myself at anything, be it yoga, software, or even adventure activities. So yeah, that's about me.
Perfect. Maybe Marinal, do you want to go next?
Yeah, I'll go next. Myself, Rinal Barua. I have total experience of 15 years in software development lifecycle. And in Simplilearn, I am working as a senior associate director. My responsibility is to understand the business goals and priority and build a scalable, efficient, and cost-effective solutions, software solutions, along with my team. And also we ensure whatever solution we build that is scalable, that is efficient, also the best suitable application architecture is followed. So in my off time, I like to play guitar. So I like music to listen or play, but that's all about myself. Yeah, thank you.
Amazing. Thanks for sharing. And last but not least, Rites, do you want to give a short intro to our audience here?
Sure, Marcus. Hi, everyone. This is Ritesh Vanchu, and I'm the cloud architect at Simplilearn. I am predominantly responsible for all the cloud infrastructure at Simplilearn and ensuring that none of our systems have any downtime. So that's a main part of my job. I'm also responsible for ensuring that any cloud solutions that we bring in are sustainable, scalable, and more importantly, secure. From a technology perspective, my areas of interest include databases, performance tuning, and decoupled architectures in general. And off work, I like to cycle around different places, and I love to do stargazing in the night. And just like everyone else here, I'm pretty excited to be a part of this group, and I look forward to this interaction.
Amazing, thank you. So if we can go to the next slide, we will be covering a few things here. We have a quite packed agenda. Obviously, we introduced our speakers. We will be learning more about what Simplilearn is and a bit of their story, the reasons why Simplilearn chose event streaming, and how that event streaming essentially helped them to support their growth, and how they did that with Ivan for Apache Kafka, and some looking ahead ways of how they use Apache Kafka and Ivan for Apache Kafka now, and how they plan to use the software in the future. So moving on to the next slides, maybe two more. Perfect. Do you want to give us an introduction of what Simplilearn is and what you guys do?
Sure, Marcos. I think I'll take this one. So Simplilearn, without doubt, is the world's #1 online bootcamp today, and it's also a world's leading certification training provider. And as you can see on the stats on the screen, the sheer number of professionals that Simplilearn as a platform has trained is more than 5 million today, which gives you a sense of the impact that we are making in the lives of different professionals. And not only that, to impart this quality education, we partner with 2,000 plus qualified trainers, and we are talking about the best in the industry here. We have a lot of offerings. There are at least 400 that we have on our website today, which we provide to different learners across the board. And our courses go through a stringent accreditation process as well. So there are 40 plus global accreditations that we have acquired as an organization. To deep dive a little bit into our offerings, if it gives a sense of what we do, we have an offering called Skill Up, which is something that's aimed at students and general learners across the world for their upskilling. And the beauty of it is that it's completely free of cost. So you can access our platform, go through all the upskilling, and Simplilearn doesn't charge you for that. So that's our Skill Up offering. Apart from that, we have our master programs, which are programs that give you subject matter expertise in a focused area. Now, that area could be cloud, machine learning, data science, or cybersecurity. Any of these areas that are in demand in today's professional careers. And last but not the least, we also have university boot camps and PG programs, which are programs which are curated in partnership with different universities. And these are top universities in the world. And they provide industry recognized certificates for leading skills to our learners. So to sum it up, Simplilearn provides a blended learning experience to all our learners in the form of live classes, hands-on labs, as well as industry-relevant capstone projects. I think that kind of sums up what we do as an organization.
Amazing. Yeah, this is great to hear from you guys, and amazing work that you do both on the upskilling students and young professionals all the way to the master's degrees. It's great to see what you do. Maybe you can tell us a little bit more about how your users currently interact with your website, or what we've been discussing about the learning management system, the LMS platform, right? To give us a bit of context about what the interaction looked like before implementing event streaming. And maybe we can start then diving deeper into the different use cases and the reasons why you chose event streaming for your platform.
Yeah, sure, Marcus. I'll take this up. Initially, I'll just take a couple of minutes just to explain how user interacts with our website, and then probably we have our 3 different use cases defined where we'll deep dive further. Just to explain how the user interacts with our Simplilearn system is, see, we have one pre-sale system that is simplilearn.com, and we have one LMS system, learning management system, that is lms.simplilearn.com. So all the pre-sale activity happens. The user comes from primarily two different channels. One is from our organic traffic, where user comes to Google search and they find relevant programs we offer. From there they come to our website, and our website enables them to actually go and make the payment, drop a lead. There are two things, where the learner can go themselves to make the payment and enroll for the designated programs. And also we have sales team sitting in, and they are supporting the customers, whoever is like putting some inquiry about any courses and all. Our sales team reaches out to those users, and they help them to enroll for the programs. That is one thing. There is one area from where the user comes to our website from organic traffic. We have also marketing campaigns from where a marketing team executes a lot of marketing campaigns to bring the traffic to our website, and based on user choice and their interest, they can actually enroll for the courses. Then post enrollment, post payment, once the learner makes the payment in our website, that's how their LMS journey begins. We have one interface called set up your account. Then once user completes the account setup, then we take user to our learning management dashboard system, where they can see whatever course they have just enrolled, they can have the access. And on click of that particular program, they can go inside, and they can see, okay, what all are the materials, what all are the different learning components included in that particular program. And definitely, as Ritesh has explained, so once they start their learning journey, we have the blended learning experience for them. We have online self-learning videos, and we have live virtual classes where our trainers directly interacts with our learners. Also, we have mentoring systems. Whenever any learners are actually going through some challenges, they definitely our trainers supports them through some mentoring sessions. And also we have hands-on lab integrated with our system. User don't have to go out of our LMS. We have the integrated lab experience in place. And also we have capstone projects. I think that's how they go through their entire learning progress, Marcos.
Perfect. This is great. Maybe if we go to the next slide, we can start looking at some of the reasons why you chose event streaming, and look at the different use cases and the overall benefits that event streaming has provided to you as an organization and a technology team at the end of the day. What does your architecture looks like, especially when it comes to the overall kind of like learning and cohort management applications that you're building?
All right, I think I could probably go with that. So for our architecture, and I think as most of you guys already know here, traditionally all the information on dependent systems have been updated either using batch processes or some backend functions, right? And the need for real-time updates was the reason we started writing microservices and APIs for us also, we were using the same thing. And at some point when we were revamping our LMS, we started, we were thinking in line to capture user events, right? To understand their behavior, how also, let's say, the learning progress they're making, how is their course progress going. So this information was important not only to the individual users, but to enterprise customers as well. And that was mainly to gauge how their course progress is going and how the certification eligibility is there. And so some of these events actually were supposed to update our dependent systems, right? And users, also the user screens should have been updated in real time. And the initial plan again was to use the APIs to do the updates in real time. But then the thought was that the success of these APIs or requests will depend upon all the downstream systems that were getting updated. Now that meant requests will keep waiting, right? And as you know, waiting requests means adding load to our systems, and then that would impact our application performance also, and it would also impact our ability to scale in long term, right? And for the same time, we were planning another new application where we were supposed to gauge, not we as in like our users, which were mainly our customer success managers and our trainers. They were supposed to gauge user data in real time, and then provide any assistance or help that was required during the user experience or the training in real time. So now these requirements required us to mainly look for a system who would help us to capture real-time events and then do data evaluation in real time, and also had a streaming capacity as well, right? And that was also running in the background without impacting our user experience, and that is where Ivan Kafka came in, and that looked as a right candidate. And now, I mean, onwards, Mrinal will probably explain you the use cases on how we were using it. But this is where our journey started. So yeah, Mrinal, on to you.
Yeah, thank you, Kusun. Yeah, so we have, as we discussed, that we have taken a couple of use cases here to go little deep, just to go little deep to discuss those points. But as a part of use case one, I think this is all about learner and cohort management application. So this is one very important use case, I mean, that really helped us to solve a major problem. Yes, so when we talk about the some operations, for example, we are assigning one program on or cohort to any learner, and then let's say we are editing some classes. It means that, so as Kusum has mentioned, so we have the learner success group sitting, and they needs some real-time data to be transferred to a different system. Here the problem is, I mean, how to transfer this data from one system to more than one systems was the problem statement here. So initially we have started developing our real-time API calls to relay the data from one system to multiple systems, and up to one set of time it was working very well. But when our user growth increases, and we have also increased our offerings, that's how we have started seeing the challenges to relay the data from one source to multiple destinations. That's why we have started evaluating how we can actually decouple the system to that will help us to support the scale, also to increase the number of offerings we have, also the number of users enrollment we can support. Then as a part of that evaluation, we found Apache Kafka is having one capability that is called as CDC, Change Data Capture. So we have explored that capability from Apache Kafka, and then we found it very useful for our use case, which will be completely helping, which will completely decommission the typical API integration. So as a part of CDC integrations, what we did was, we have just taken one small POC just to configure Debezium connector with Apache Kafka, and this CDC connector was actually looking into our MySQL bin log, and whenever any data changes happens, so automatically Debezium was able to stream this data from MySQL bin log to the designated Kafka topic. And so this data change might be creating any new data or editing any existing data. For example, so if I am coming back to the previous point, when we are assigning any programs, then similar data we relay from one system to another systems, then this solution was helping us to bring this data without making any API call from one system to other systems. Also, whenever any class schedule edit happens or any changes happens with any existing data points, so at the same time, CDC connector Debezium was able to stream the changes from MySQL to to the designated topics, and we were able to notify our users through email communications as a part of the consumer. This is how we have started the POC, and when we saw, okay, this POC is really giving us a great result, and over the period of time, we have scaled this up, and we have gradually started covering more and more database tables to basically relay the different data points from the source to multiple destinations. And this is how, this is how we have solved not only the API latency, also data inconsistency. So in previously, before this solution, there were a couple of cases what in case of any API fails, there were data consistency issues, right? Data were not, it was not consistent across the systems. Now, as a part of this implementation, from consumer, we are able to implement the retry mechanism n number of times, and that's how we were able to solve that data consistency issue as well. Yeah, so this is all about the use case one, how actually CDC helped us to decouple our systems and decommission the typical API-based solution to the CDC-based solution.
This is great to hear, and yeah, good to hear how CDC is supporting your use case here. Moving on to the second use case that we wanted to cover today, specifically about user enrollment flows to different cohorts. Maybe we can start looking at what requirements you needed for the specific use cases and what challenges you faced with the previous tech stack that you used.
Sure. So actually, talking about cohort enrollment, so users who were enrolling into a course with us, we were adding them to batches or cohorts, right? And they will usually attend the virtual classes for that course together, right? Now, when a user comes and enrolls to a cohort, we were showing him a list of LVC classes that he can register. And that registration required us to go through multiple steps, like the ones that you see on the screen. The registration will happen, notification will go to the user, and we will update the registration count on the website as well. So multiple steps were part of this process, right? Now, later on, we wanted to automate this process. I mean, till this point, it was happening via APIs, and now we wanted to automate it. But automation, as part of automation, what we wanted to do was we wanted to enroll the user to all the LVC classes as part of that cohort, and that required n times of this process to be repeated for each class, right? Now this becomes a lot. And then we also had to update some dependent systems. Like, I'll give you an example for website. Now, if I take max limit of a cohort that we have, and now the last user is registering on our website, we have to immediately update on the website saying the enrollment is complete, right? And at the same point, if someone unregisters, we have to update it again that enrollment is open again. So this is like real-time process that has to happen. Using the existing APIs, it was working, but then the number of cohorts as they increase, that was adding latency. And also on the part of user experience, it would not feel very nice to tell a user that you enrolled into a cohort, but sorry, we are out of, we just reached our limit, so we cannot take you, right? But then we would want the real-time updates, so we don't have to go into that experience at all. And another thing was that we are adding a lot of cohorts every week. So that means it's the amount of load that might go onto our system, updating these things in real time. And the place where Kafka came into picture, that was mainly to decouple this heavy lifting that was done on our applications on any learner action that was happening, right? And now user tries to enroll for a cohort. We do that entire process on the backend, in the background, without user being impacted. He will get registered, he'll get the notification also. So the class stats will also update on the website similarly. And all these things were happening via consumers that were there, which were part of our Kafka topics already, right? Now, any errors, if there would happen, will automatically be retried, as Mrinal already explained. And this thing was being handled seamlessly on the background with the Kafka structure and without any user experience change. And so if we move to the next slide, we'll probably see what was the architecture that was being followed after Kafka. Now, in this case, the requests were being submitted just to Kafka on a learner action, and the APIs will not wait at all. So basically, the user will see the stuff updated from the background itself seamlessly without any issues. So yeah, that's about the cohort use case that was eased on with us from Kafka, and the next again use case will be taken by Mrinal.
Perfect. Thank you very much, Kusum, for all the info and background. Now, if we go to the next slide, it would be good to hear more from you guys how you have identified and improved any existing challenges with the overall LMS platform latency that you faced before.
Sure, Marcos. Yeah, I'll take this up. So we are talking a lot of things about decoupling systems, right? So that's why I think all these three cases are aligned to that. Yes, this is another very important problem segment we had in past when we have developed our learning management system, and it was working very fine with our previous architecture as well. But when our user, our offering increased, and as I mentioned in past, right? So then that offering was, that was bringing a lot of new set of users to our ecosystem that has resulted overall spike in our traffic, and hence we have started observing the challenges, the latency issue in our learning management system. If you talk about the learning management system, the very standard behavior of any learning management system is just to capture the learner's learning progress and store this progress into one system called LRS, Learner's Record System. So here also in Simplilearn, we have built the LRS system, and we're storing this data into Google BigQuery and also in AWS DynamoDB, as we can see as a part of this diagram. There is one part where actually we capture our learners information, learners progress data, and at the same time we also closely monitor the engagement of our learners, how closely they are engaged with particular modules or particular learning components, and hence we do have some activities that we capture as an event, and those events we pass on to some event platforms called Google Analytics or web-based platform. And there is second type of the events what we capture. Also, the third type of event is basically, so we do have enterprise business. Just to support our enterprise business, we do relay their learners' progress from our ecosystem to their ecosystem. It means that we have different types of integrations. We have different types of data relay happens. Based on that only, we actually pass this data to different systems. Whether it's sometimes it might be our internal system, or sometimes it might be some external systems. So yes, as I told, as I mentioned, it was working very fine. But as a part of our business growth, we have started seeing latency as a major challenge here. So hence, we have already, I think, as Kusum discussed, as a part of our tech evaluation, how to solve this problem and what could be the better solution or technology or platform we can bring to our ecosystem. That's how we brought Kafka, and we have basically designed, we have offloaded the real-time API calls to message streaming from learning management system to Kafka. Also, we have designed the consumers, and we were basically processing the messages from Kafka topic to the designated destinations. Here, primarily, we have used two capabilities of Kafka ecosystem. Number one, enterprise queuing mechanism, where there are no any aggregation happening. So just messages coming in from our ecosystem, our learning management system to Kafka topic, and consumer is just simply reading this message and passing it on. For example, logging as an event, if we capture login as an event, we want to pass this event from our LMS to WebEngage or Google Analytics. So no aggregation, nothing, no competitions. We are just simply reading the message and we are passing this on to the different platform. There is one use case, but there is one capability where we have used from Apache Kafka, and second capability what we have used is basically the streaming. The consumer is not actually passing this data as is. We are doing certain aggregations by using the streaming mechanism, and the final result, the aggregated value, we are passing from the consumer to the designated system. That's how we were able to minimize the number of API calls to the designated destination systems. So that's in a brief. Just we have introduced one intermediate layer, that is Kafka, and Kafka was taking care of accepting the different events, whether it's related to progress or it's related to some event passing to different event-based event platforms, or also probably sending this learner's progress to any enterprise clients. So we have designed the entire topics, Kafka topics, according to that, so that LMS, our learning management system, is streaming the relevant message to the relevant topic. And we have also created some consumer groups in Kafka cluster. And according to that, we have registered a couple of consumers, which was doing the relevant actions, whether it's just sending this message to the destinations, or there are some aggregations needed. No, that's where we were using streaming. We were doing a lot of aggregations and streaming this data and passing this to the third party destination. All right. So we definitely have seen the beauty of this implementation, Marcos. So before and after of this implementation, now if you look at the outcome of this implementation, right, our latency is completely disappeared, and we are also able to give the best experience to our learners, because all these events are actually streaming and going to the designated system, which is actually acting, or probably we are presenting the data back to users, which is actually, for example, user progress, how much time they are spending in our platform. We're able to pass these informations to the learners almost real time. But yes, that is using this decoupling system. And the third thing is basically now scale is not a problem for us. So if we offer new programs, and if our user base increases from X to 2X, 3X, 4X, I think that scale is not a problem. What we'll do is simply we'll go to our Kafka ecosystem and we'll create new partitions, and we'll register new consumer group, and we'll align a couple of consumers according to that. So that's how we were able to solve the latency problem from our learning management system. I think that's all about the third use case. I think it is really helpful for us to solve the bigger problem. Now I think we are at a very good place to support the scale and give the better experience to our users. Marcos.
And guys, just adding to Mrinal's point, so all these events that we're talking about, these were not only flowing from our platform, as in like our LMS web application, but also from our mobile application as well. So coming from all these sources, the events were handled through one backend system, Ivan Kafka, as Mrinal just mentioned. And the increase that we saw of our scale of users that went up with Skill Up offering went pretty smooth for us, right? And providing a great user experience alongside reading users' data, and in fact for SkillUp, which is like a free offering for us, right? We provide recommendations and offering suggestions to users in the real time as they progress through the course, and that is mainly all happening via the data that we capture and process while they're taking the course alongside itself. So yeah.
Perfect. Thanks for the insight and input, both Marinel and Kosum. Great to see how Kafka is helping you here with its scalability to really improve your latency requirements here. Now, moving on to the next slide, looking at some of the overall benefits that you guys had from implementing an event streaming system with Kafka and Ivan for Apache Kafka. We have a poll here for the audience just to see which event streaming technology are you using at the moment. We have a few options here available, and we will be having the poll up for a few moments to capture your respective options and technologies here. Okay, we'll be stopping the poll now and seeing the results. We see a few people using Amazon Kinesis, some using Apache Kafka already, and we have a few more people not using event streaming technology at the moment. So I hope that the specific webinar provides a bit of insight and support in what use cases and how another company or another organization is using event streaming to support their scalability and support their needs when it comes to scaling their systems successfully for growth. Going back to the overall benefits of rolling out event streaming in the organization, what do you see those being, and how would you describe these overall benefits from rolling Kafka into your organization? If we can go to the next slide. Yeah. Thank you, Ritesh.
Okay, so coming specifically to the benefits that Ivan Kafka has brought in, if we can at a high level break this down into 4 points. So speaking about the first one, supporting scale up at scale, we did talk about scale up, our free offering. And when we introduced that, over a very short period of time, we saw our traffic go 9x. So if you're catering to 1,000 requests, those became 9,000. So just to give you an idea of the scale. But thanks to having a decoupled system in place on Ivan Kafka, the scale never really constrained the systems. So for an end user, the experience was still seamless. So that's definitely a big plus that we saw through this decoupled architecture. Coming to the second point, that's around supporting growth in our product offering. So as we grew in numbers, we also had newer products, newer partnerships with universities. So we have a partnership today with more than 10 top universities in the world, and each university has a certain offering that we are driving. This translates into more students, this translates into a higher number of classes, more cohorts, and additional scheduling requirements. But again, I mean, as we spoke before, this never was a problem because we were decoupled and all the heavy lifting happened in the back end. Moving on to the third point, that's real-time learning outcomes. Now, because the kind of solution that Kafka is, for example, learners' progresses were near real-time, and when learners' progress was near time, what happens when people were able to unlock their achievements? They would get their certificates on time, they would share those on social media platforms and get recognition through recruiters, etc. So it meant immediate outcomes there. Not only learners, but even us as an organization, our operations team used to have information more readily available and decisions could be taken faster. And if someone was facing a challenge, it could be addressed on priority. Lastly, talking about seamless operations, here I'm putting my DevOps hat, and running Kafka in-house, as we all know, isn't the easiest of things, to be very honest. I mean, Kafka comes with a lot of overhead in terms of managing the zookeeper, ensuring uptime, etc. But what our partnership with Ivan has done is it has taken all that heavy lifting away from us. We have a very user-friendly Ivan console where we configure our requirements and our clusters are up and running. And we've rarely had issues where there were any sorts of glitches. And whenever those were there, we had our customer service team jumping in and helping us out, recover and make sure that operations are seamless. So I think it's been a great 3.5 years working with Ivan, and there's quite a lot that it's changed in terms of our systems, and most of these changes are very positive.
Perfect. Thanks a lot, Ritesh, for all the input and insight, and thanks for the kind words about our customer support team. Moving on, I do see a couple of questions, obviously for the audience as well. If you have your questions, we're happy to see them in the questions tab. What results did you see after implementing event streaming with Ivan in general, and how has this resulted in streamlining your processes? Kusuma, I think you are on mute.
Oh, sorry. Yeah, I was. So in general, as I already told, our architecture always has been making real-time updates, but that using APIs. Right now, all this adds loads to our systems. That add load to our databases. It add load to our applications. But then using Ivan, we are doing all the real-time processes, but then in the background, right? I mean, whatever we need to process as a queue real-time using an API, and the API, rather than waiting for the response to happen and the user experience being impacted by that, we will push it to a consumer, which will spread it across to different topics. I mean, we will spread it across to different topics, and then it will all get processed in the background. And I mean, user will see updates, but that will be happening in the background without impacting. The only impact that we will see for the user is real-time updates, giving him even better experience than before, where the request was waiting in the background and adding load to the systems, and also otherwise impacting our systems on the go. So I hope that answers.
Perfect. Yes. Maybe another question from my side. From an operational and maintenance perspective, I think Ritesh briefly touched on it before. Have you seen any improvements, or can you explain what your operations look like before moving to event streaming and Kafka, and how that has evolved, or how that has changed now that you have Ivan Kafka implemented in your day-to-day operations and maintenance for the infrastructure?
Fish, do you want to take that?
Sure, guys. I mean, as Mrinal and Kusum explained, the architecture before Ivan really came into picture was mostly API driven. Most of the challenges that we had, those built up over a period of time as additional integrations came in, and we started seeing slowness. So it was a problem that we had to tackle sooner than later. The additional requirement that came in around the cohort management system, it sort of came in as a blessing in disguise, where we had to look at our architecture as a whole and use that opportunity to bring in a solution which not only addresses a new problem at hand, but also addresses some of those existing challenges which we covered in use case 3, where latency was building up. So this was as far as the difference that bringing in Ivan made. Specifically from an operations perspective, while Kafka as a solution was definitely on our mind, the biggest put off was running in Kafka cluster all by ourselves as an on-prem sort of a setup, which I did touch upon. Thankfully, we never had to go there, given that Ivan's offering was available to us, and we sort of grabbed that with both hands and set up our infrastructure there. So it sort of solved both the problems in one shot. I hope that sort of answered your question.
Indeed, yes. Thanks a lot for the question, Ritesh. Another question that I see here, you mentioned that you have CDC from MySQL. What other technologies do you use to stream data to Kafka to or from? And can you explain what other components are included in your tech stack?
Yeah, I'll take this up, Marcos. Yeah. So if we talk about CDC, currently we have extensively used CDC, by using WSM connector with MySQL only. I mean, apart from MySQL, we have not used CDC connector with any other database technologies. Now, if we talk about MySQL database, so initially we have started with one database with very minimum tables just to see how this performs. Then when we have seen the beauty of this technology and pipeline, then gradually we have started scaling this up to cover more than one databases, because we have different applications in place, and different application is actually dealing with different persona from users perspective, right? Where we need to capture the changes of this data from different database and pass and relay this information to different destination systems, right? Hence, I think, yeah, I'm coming back to it. So as so far, yeah, we have used only with MySQL, but yes, more than one databases we have covered as a part of CDC pipeline as of today. Yeah.
Perfect. Thanks for answering the question, Reno. I do see a follow-up here, which is around how long did it take you to migrate from your previous API-based to event streaming with Ivan and Kafka? And did you run into any issues through the migration process that you had to overcome?
Right. Yes, I think the plan what we made was just to not decommission everything on our previous solution, then go with Kafka based CDC based solution. What we did was our the previous API based system was still up and running, but as a part of POC, we have started using a CDC connector for certain use cases. It means at the same time we were running with API based application also, as well as for CDC based solution. So I think if we talk about the timeline, I think the entire migration was we did the migration in batches. We did not do the complete migration in a week or 2 weeks or so. We have also looked at how this migration is going to impact our business operations. That's why we have broken it down into multiple pieces. Okay, so and we planned the migration accordingly so that it won't impact anything from into the business side. So net probably over the period of 1.5 months time, we were able to move on from our previous API based solution to the CDC based solution. And also, if we talk about the challenges, yes, we definitely we have experienced a couple of challenges where we were able to solve those challenges definitely with the help of Ivan's support team. This DBGM connector also offers a couple of configuration, I mean, whether how we are going to deal with DDL, how we are going to deal with DML, right? So whenever the DBGM will actually keep listening to the bin log of MySQL service, right? Then which query to be skipped, which query to be looked at, right? We can do a lot of configurations there. I mean, so I think I do remember there was one instance where one DML was triggering some issue. Then we have deep dived and we have also looked at the log. Then we identified, okay, this was the exact DML query that was actually stopping the the pipeline it was stopping the data flow from MySQL to the topic. Then what we did, we again, I think Ritesh has clearly mentioned, Ivan provides one very nice and simple UI console where we can go and do a lot of configurations there. Yes, we were able to make some small changes into the configuration of the DBGM connector. Then after the changes, yeah, I think again our data pipeline was up and running. Yeah, but that's all. So I think definitely we can skip. We can configure, okay, which DML to be skipped, which DML to be considered, or which DDL to be skipped, which DDL to be converted. Also, we can configure which database, which table, right? There are a lot of things I think we can do, as a part of that DBGM configuration. Yeah, I think I hope it answers the question.
And just to add one more thing to Mrinal's point on part of migration, see, we already had a few APIs that we knew of, and when we were migrating, all we needed to do was just lift and shift that same logic from there and add it to the Kafka consumers. And I mean, it did not require us to recode anything. All we did was point these APIs to the topics rather than doing some bigger changes. So migration ideally was like copying, more of a copy paste than rewriting everything. So that was a big plus here.
Perfect. Thanks for answering the question here, and thanks for the insight on the migration process. That's something very important, I think, for anyone considering to move into event streaming right now. Last question that I see here is whether you run Ivan Kafka or Kafka in general into any cloud providers, and if you run it on multiple cloud providers, if you replicate your clusters across those cloud vendors.
I'll take
We
this
haven't
one.
done cross cloud yet. Yes, Ritesh, please go.
Sorry, Kusum, if you started.
I'm sorry, Ritesh, were you taking that? Okay. So I was mentioning that we did not go cross cloud, but then we have been using the current instances that we are using are from AWS, and that has pretty smoothly been working for us. We are able to scale whenever required. We were able to upgrade easily onto the next setup that was there, and the scaling happened pretty smooth. So I mean, we have stayed on this one AWS cloud itself, and it has worked pretty good for us.
Thank you for the input. These are all the questions that I see for now. Let's wait for a couple more minutes. Maybe some more people have a few more questions for us. In the meantime, I did want to raise that we do have a trial for our Ivan Kafka offering, which provides $500 of credit for a free trial. I think it's for 30 days, if I'm not mistaken, where you can try the Ivan Kafka service that the Simplilearn team has been using in the past and has been sharing their experience with. Let's wait for a couple more minutes to see if more questions pop up for the audience. If you have any questions, please let us know. Overall, maybe for you guys, for our speakers, how has your experience with working with Ivan and our team has been? Have you had any issues, or has it helped you, scale your infrastructure in general? Maybe
like I
Ritesh
mentioned, like I mentioned, I think see there are hiccups because infrastructure infrastructure breaks. Systems are supposed to break, but what's important is how fast do we able to recover that, and that's where I think it's been a really good partnership. We've worked with some of our customer support associates for the last couple of years, and help came very fast. Basically, there's a key differentiator for me. So yeah.
Perfect.
And plus, even adding to another issue that we faced, but that's on the logical end. So let's say if we have any issues as part of new releases that happen, right? Like let's say something got missed as part of a release, we were easily able to replay. And we found that out in the consumer itself that something is the data is not going right. But then the best part is we were able to replay those events, and then that there was no data loss on our end. So Ivan helped in that case as well.
Right. I think there are a couple more questions. I'm trying to find those. Yeah, I see another question. How large is your cluster in terms of number of nodes and their memory or CPU?
Yeah, it's a 16 GB cluster from what I last checked. We are on the business 8 plan with Ivan. So yeah, I think it's a 16 GB cluster basically.
There are 3 nodes cluster.
And another question that I see here, how are we updating the user with any required response after the Kafka events are being processed? So do you update those, I assume, through another system, or is it on the same system?
Yeah.
So, okay.
Kusum, you want to take it up?
Yeah, that's fine. Go ahead.
Right. How exactly we are updating the status once Kafka message is processed? That's the question, right, Marcus?
Yes.
I mean, that depends, case by case basis. For example, we are using, if we talk about the course progress, right? I think that is, I mean, that just to provide the experience to our learners, right? I think there are a couple of things involved there. For example, as a learner, I am having some progress. I am actually attending one class, or I am watching some WSL videos. I progress that from like 0% to 10%. We are capturing those events and we are streaming these events to the Kafka topic. And we do have consumers in place that actually updates our backend database systems. And that's how we update the database systems immediately. But in other side, how exactly we are giving the best experience to the user is, so we have one front-end layer, JavaScript layer, which is actually listening to the database system on real time. It means whenever any changes happens in the database, immediately it is sending the data back to the JavaScript layer, where user is able to see the changes. For example, here where he progressed from 0% to 10%, the data went to Kafka topic through the streaming. Consumer has processed that and updated the backend system, and our client is JavaScript layer is actually listening to that particular node or particular database, and it's able to retrieve the data on immediate basis. That's how we are updating the database system once we process the message. I think that is one use case. Just I would like to I wanted to just explain. Right.
Mm-hmm. Perfect. I hope this answers the question. Great. I don't see any other questions for now. I think we're close to the hour. We have a couple minutes left. What I did want to say is a huge thank you, very big thank you to all of our speakers, Kusum, Ritesh, Marino. It's been great working with you on the webinar. It's been great having you today and hearing really how you have decoupled your systems, you have decoupled your infrastructure and moved to event streaming to help you scale for growth. So it's been really great hearing from you and your experiences. I do want to say a big thank you. And for any follow-up questions, we will be sharing the recording. Feel free to reach out to us through the Ivan channels for any questions, and we can make sure our presenters here will receive your questions if you have any questions following up this webinar.
And thank you, Marcus and Ivan team, for giving us the opportunity to speak about our experience here. I think how exactly we were able to solve the scale issue or latency issue in our ecosystem. And yeah, I mean, it is really a great discussion great forum to actually share our experience here. Thanks.
Great.
Amazing.
Yeah, thank you, Marcus and the Ivan team.
Yeah, thank you guys.
Thanks, everybody.